Now we come to wind energy. Again, let us think to ourselves, what can be the possible impacts of wind energy? Here shown is the LCA of a wind turbine, right from the resource extraction, transport, to the material manufacturing, the turbine construction, all the parts of the turbine, including the basement, tower, rotor, etc. Finally, the operation of the turbine, its decommissioning, and then its disposal. This goes to show that not only is the production of energy considered for the emission of greenhouse gas emissions, but the entire process. Water use. As I mentioned earlier, there is no water impact associated with the operation of wind turbines. There is some water used to manufacture steel and cement for the turbines. Land use. Wind farms are often built on land that has already been impacted by land clearing. The vegetation and ground disturbance required for wind farms are minimal compared to coal mines and coal powered stations. Less than 1% of the land is used for the foundation and access roads, while the other 99% can be still utilized for farming. Turbines are not generally installed in urban areas. Why is that so? First, the value of land is high, the buildings interfere with wind, and the turbines must be sited a safe distance from residences, hence giving it a setback and an additional constraint. Solar power, as I said, has affected agricultural activities. Why not wind? The land can be still used for farming and cattle grazing. Livestock is unaffected, and as we see in the picture, livestock often graze near the wind turbines and use them as rubbing posts or for shade. Greenhouse gas emissions are very little. Wind turbines have one of the lowest global warming potentials. The median value of greenhouse gas emissions lie between 11 to 15 grams of CO2 equivalents per kilowatt hour, depending on whether they are offshore or onshore turbines. Geothermal energy. Geothermal energy is the heat within the earth. It is a renewable energy source because heat is continuously produced inside the earth. Geothermal power plants use heat from deep inside the Earth's surface to generate the steam used to make electricity. Geothermal heat pumps tap into the heat close to the Earth's surface to heat water. Environmental impact of geothermal power. Land use. Land subsidence, a phenomenon in which the land surface sinks, is sometimes caused by the removal of water from the reservoirs. Most geothermal facilities address this risk by re-injecting wastewater back into these empty reservoirs after the water's heat has been captured. There is also a risk of earthquakes because these geothermal power plants are sited on geological hotspots which tend to have higher levels of earthquake risk. Some systems, known as the enhanced geothermal systems, involve processes in which the water is pumped at high pressures to fracture the underground hot rock reservoirs, similar to the process of hydraulic fracturing used for capturing natural gas. The earthquake risk is minimized by siting plants at appropriate distance away from these fault lines on the Earth's surface. There is a question. How do you think the Pohang earthquake was caused? Well, it would be a surprise to know that it was triggered by a geothermal power generation plant. The 5.4 magnitude earthquake rattled the city of Pohang in November 2017. Pohang's enhanced geothermal system cracked open the rocks to infuse water with high pressure to bring the heat to the surface. Drilling and infusing process initially created many small micro-earthquakes around the facility, and they all accumulated due to the pressure from the water injection over time, ultimately leading to the second largest earthquake in South Korea. Water use. Most geothermal plants re-inject water into the reservoir after it had been used. Hence, there is not that much of water use. However, not all water removed from the reservoir is re-injected because some is left as steam. In order to maintain a constant volume of water in the reservoir, outside water must be used. The amount of water needed depends on the size of the plant and technology used. However, because reservoir water is dirty, it is often not necessary to inject clean water. For example, the Geysers geothermal site in California injects non-potable treated wastewater into the reservoir. Coming to the greenhouse gas emissions, fluids drawn from the deep earth carry a mixture of gases, notably CO2, H2S, methane, and ammonia. These pollutants contribute to global warming, acid rain, etc. Around 45 kg of CO2 equivalent per megawatt hour of emissions is generated. Hot water from geothermal sources may also hold trace amounts of toxic chemicals like heavy metals including mercury, arsenic, and boron, antimony, and salt. Biofuels. Biofuels are any fuel that is derived from biomass, that is, plant or algae material or animal waste. Since such feedstock material can be replenished readily, biofuel is considered to be a source of renewable energy, unlike fossil fuels. There are various ways of making biofuels, but they are generally used in chemical reactions, fermentation, and heat to break down the starches, sugar, and other molecules in plants. The resulting products are then refined in refineries to produce a fuel that cars or other vehicles can use. Coming to the environmental impacts of biofuels. There is a large-scale deforestation of mature trees which absorb much more CO2 than the sugarcane which is planted. There is also soil erosion because of that, loss of habitat, and reduction of biodiversity. Shown in the picture is the Indonesian palm plantations. Palm biodiesel is an alternative fuel derived from palm oil and can be used in compression ignition engines, that is, diesel engines, without any modification. It refers to methyl esters derived from palm oil through a process known as transesterification. Water use. Pressure on water resources occur in at least two ways. One, due to the irrigation of crops used as feedstock for the biodiesel production, water is needed. And secondly, water use in the production of biofuels in the refineries are mostly used for the boiling and cooling processes. Greenhouse gas emissions. Biofuel aims to be carbon neutral or even carbon negative. Carbon neutral simply means that the carbon dioxide released during the use of the fuel, that is, through the burning to the power transport or generate electricity, is reabsorbed and balanced by the carbon absorbed by new plant growth. These plants are then harvested to make the next batch of fuel. This is a representation to show the grams of carbon dioxide produced per megajoule of energy on the x-axis and different fuels used on the y-axis. We expect coal to be the highest, which can be seen, and then come the different biofuels like sugarcane, molasses, and wheat. Let us now go on to see hydropower. There are two types of hydroelectric power generation systems. One is the pumped storage and second, run of the river. Pump storage is shown in the diagram. It involves two bodies of water, which is the upper and lower reservoirs. At times of very high electricity consumption on the grid, the water from the upper reservoir is carried downhill, drives a turbine and a generator to produce electricity, which is used to meet the demand. When the demand is low, electricity is taken from the grid to power a pump that sends water from the lower reservoir back up to the upper reservoir, where it can be discharged again to drive the turbine. In this way, the water in the upper reservoir constitutes a stock of gravitational potential energy, ready to be used when needed. The stored energy is proportional to the volume of water and the height from which it falls. The second, which is run-of-the-river system, includes running water which is diverted from a flowing river and guided down a channel which leads to a generating house. There, the force of the moving water spins a turbine and drives a generator. The water is fed back into the main river further downstream.
In this video, we're going to be discussing pumped hydroelectric power stations or pumped hydroelectric power plants, and we're going to be looking at some of the potential environmental and ecological impacts associated with their use. We're going to use the example of Côte-Trois-Ponts, which is actually based in Belgium. So here we have a photograph of Côte-Trois-Ponts, and what we see is we have two upper reservoirs which are used to deliver water into a lower reservoir. Now, with it being a pumped hydroelectric power station, when there's an excess of power being generated on the grid, water is pumped from the lower reservoir through tubes up to the upper reservoir. And when the demand for electricity on the grid is higher than what's being supplied, the water is released from the upper reservoirs back through the pipes and through the pumps, which will now be acting as turbines. And that's going to produce electricity back to the grid. So before we consider some of the impacts associated with this, let's first of all consider some of the benefits. Now, one of the challenges of generating electricity through renewable sources is storing that energy. It should be apparent that things like wind energy and solar energy are somewhat unpredictable. At times we can produce an abundance of energy, and at other times there's a shortfall in our requirements. So energy storage is going to be a huge focus in the future as we convert more of our energy production to renewable sources. And there's actually relatively limited technologies for storing electricity. So that's the first benefit of this type of station. Another huge benefit is that we can deliver on-demand power. So here in the UK, the National Grid is responsible for monitoring usage on the grid, and then they would actually contact power stations to either increase or reduce their production of electricity. The huge advantage with this type of plant is that it can provide that on-demand electrical power, and in fact Côte-Trois-Ponts can provide up to 1200 megawatts of power for up to 6 hours. Now, just to put that into context, that's roughly the same power production of a nuclear power station. Or as another example, the largest offshore wind turbines of this time are 10 megawatt machines. So this can provide the same amount of power as 120 of the biggest offshore wind turbines. And don't forget that wind turbines don't always produce their rated power. It has to be certain wind conditions for them to produce their 10 megawatts. So this power plant has the potential to produce a huge amount of electricity on demand. Now, another huge benefit is that this is clean energy. We're not burning any fossil fuels, we're not producing any carbon dioxide. But nonetheless, there are still some ecological and environmental impacts. The first thing to consider is the impact this might have on fish migration. The way that the lower reservoir was created here was by damming the natural flow of a river. So that's obviously going to affect the flow of the river and potentially the creatures living in and around the river. Another potential impact is over land use and habitats. The two upper reservoirs we see here are man-made. We can see around the outside that there's forest area, so the likelihood is there's been deforestation in order to create these two upper reservoirs. By doing so, the likelihood is that some habitats have been disrupted as a result. So this is obviously an important consideration when constructing a new power plant of this type or any other type. Another potential impact is the impact that this has on the temperature of the water. When the water is delivered through the pumps or returned through the turbines, that's actually going to cause the water temperature to increase. So these are all things that need to be considered. Now, generally, when new technologies are being considered for a new site, an environmental impact assessment will be carried out in order to look at all of the possible impacts and then weigh those up against the potential benefits. And that's exactly what I want to encourage you to do. Because if we look at impacts in isolation, it would be easy to put forward an argument as to why the development of this plant should never have gone ahead. But if we consider the benefits and we consider the alternatives, then that's likely to sway the opinion in the favour of developing such plants. So what are some of the alternatives to pumped hydroelectric power? Well, as mentioned earlier, one of the challenges we face is storing energy, and there are very few technologies for storing energy. But what we do have is technologies for producing on-demand power. Some of the different technologies that are available are nuclear power as an example, and we also have biomass plants. Biomass is a carbon-neutral crop which absorbs carbon dioxide when it grows and then releases that carbon dioxide when it's burned. So it's what we call carbon neutral. Some of the more traditional alternatives are things such as our gas-fired and our coal-fired power plants. The advantage of these types of plants is when demand increases, we can simply burn more fossil fuels. It should be apparent that there's impacts associated with that as well, because then we're producing carbon dioxide, which potentially has a damaging impact on the environment also. So in this video, we've talked about some of the benefits of pumped hydroelectric storage plants, and we've also considered some of the impacts. Hopefully by considering the alternatives, it will help to stimulate some thought and enable you to evaluate whether you believe that pumped hydroelectric storage is beneficial or whether the environmental and ecological impacts outweigh the potential benefits.
Additionally, there are some concerns. Land use. Hydroelectric plants in flat areas tend to require much more land than those in hilly areas or canyons, where the deeper reservoirs can hold more volume in smaller area. Flooding land for hydroelectric reservoir has an extreme environmental impact, including destroying forest wildlife habitat and agricultural land. Fish and other organisms can be injured and killed by the turbine blades. There is a question. Reservoir water is usually more stagnant than normal river water. So, how does that cause an environmental impact? The answer is that the reservoir will have higher than normal amounts of sediments and nutrients, which can cultivate an excess of algae and other aquatic weeds. These weeds can crowd out other river animal and plant life, and they must be controlled through manual harvesting or by introducing fish that eat these plants. We can see in the diagram that there is indeed a collection of fine sediments and coarse sediments due to the difference in height. Did you know? In addition, reservoir water is typically low in dissolved oxygen due to the excessive algae growth, and it is also colder than normal river water. When this water is released, it can have a negative impact on the downstream plants and animals. Hence, to reduce these impacts, aerating turbines are installed to increase the dissolved oxygen, and multi-level water intakes can help ensure that the water released from reservoir comes from all levels of the reservoir rather than just the bottom, which is the coldest and has the lowest dissolved oxygen. Greenhouse gas emissions. The global warming emissions produced are mainly during the installation and dismantling of the power plants. Plant material in flooded areas decay in an anaerobic environment and forming methane, which is a greenhouse gas. The life cycle emissions can be over zero point 0.5 pounds of CO2 equivalent per kilowatt hour, as compared to 1.4 and 3.6 pounds of CO2 equivalent per kilowatt hour for coal. We are done with the renewable sources. Now let us move on and see what are the environmental impacts associated with non-renewable sources.